I'm going to talk to you a little today about how we regenerate the squash collection here at the North Central Regional Plant Introduction Station. The squash collection that's held here at the Ames, Iowa station is just the Cucurbita pepo. Some of the more common names for Cucurbita pepo are acorn squash, jack-o'-lanterns, pie pumpkins, zucchini, delicata, and there are also some ornamental gourds like the little tiny pumpkins, both the white and the orange. And then there are the bicolor spoons that you see that are sold in farmers markets. And there are some accessions that livestock consume. There are 4 other locations with the National Plant Germplasm System that have other species of Cucurbita. And each is more suited to those type of species to maintain them. The Cucurbita pepo collection has about just under 1,000 accessions, and the accessions range from more cultivated to very wild. The wild material are more like your ornamental gourds. They're small and they're hard. The larger ones can be as big as we need a front end loader to move them because they're so large. The collection is, it covers accessions from all over the world. The wild material, there's some wild material that's native to the U.S. and Mexico, but the majority are not native to the U.S. and they come from other locations. A lot are from South America, Central America, Africa, and then we have some from European countries. They come from all over. The squashes are really pretty easy to grow. We regenerate them only if the seed lot is declining in viability or if we are low on our distribution samples. What we do is we start the seeds in greenhouse in peat pots in early May, and then as the seeds germinate, we will do squash mosaic virus testing. It's tested via ELISA. Any seedlings that test positive for squash mosaic virus are eliminated. And then when the plants are sufficiently large enough, we will transplant that into field cages out in the field. We grow our pumpkins and squash, as well as most of our vegetable crops here, in cages, partly for controlled pollination, but also to protect them from harmful insects and predation. Insects that are harmful can fly up north carrying diseases that will impact our regeneration efforts, but also in the case of squash mosaic virus, that's a seed-transmitted disease. So we want to protect our plants and eliminate any plants that might have that disease. The screens also protect from predation by wildlife. It can protect the plants from other insects that don't necessarily transmit disease, but can consume the plants and destroy our populations. The field cages are 15 feet by 7 feet tall and 40 feet long, and it takes 15 people to set these up. So it's quite a production to get them all out in the field and screened. But once we get the plants in the cages, it's very simple. We usually put 24 to 36 plants in the cages, and as the plants begin to flower, we look for male and female flowers, and once both male and females are present, we will introduce honeybees or bumblebees into the cages. The pollinators are left in the cages for the whole summer. We usually stop pollinations at the end of August because our field season isn't long enough. Any fruits that are produced after September 1 generally do not mature in time, and we don't have good quality seed. But once the bees are taken out, we just monitor the growing of the fruit, and anything that starts to decline, we will harvest those. Otherwise, we wait to harvest until we have a threat of a frost. And we harvest all of the fruit, and they're held in wire crates that are lined with plastic. And these crates can be stacked in our storage building, and then we allow the fruits to mature a little bit longer, and then we will extract the seed by cutting the fruits open and scraping the seeds out by hand, and that usually occurs around November 1st to Thanksgiving. Once the seeds are extracted, they're dried in screened drawers in a dryer cart, And the seeds are further cleaned using an air column separator. Once the seed lots are cleaned, we'll do viability testing, and eventually these are stored and made available for researchers and breeders around the world.